G'day and welcome to the second video on integration of polynomials. In this video I'm just going to go through a couple of examples as to how to do this, remembering that when we integrate we add 1 to the power, divide by the new power, and we also divide by the diff of the inside, although that won't be appropriate for some of these questions. So I've got this example here, my first one. I've got x squared plus x on 2 plus 3. Now if I want to, I can integrate these things individually. In fact, I don't know any other way really. But I guess what I mean by that is that you could do this, x squared dx plus the integration of x on 2 dx plus the integration of 3 dx. But I guess I don't really want to do that for this one. I just want to do them all individually and write the answer. So I've got x squared, I add 1 to the power, becomes x to the power of 3, divide by the new power, which is divide by 3. X on 2, I add 1 to the power is 1, so x squared on, and then that becomes 4 because it's on 2 times 2. This one's a little bit tricky, but it's not that hard, but 3 is 3x to the power of 0. Okay, I add 1 to the power, becomes 3x to the power of 1, divided by 1. And then I've always got my random plus c on the end. Okay, that I need to have that every single time. For this one here, I've got x times x plus 3. And now I told you in the last video that you can't use the product rule for these kinds of questions. You have to, there's no other way of doing this other than expanding them first to be x squared plus 3x and then go from there. Okay, so this one would be add 1 to the power becomes x cubed on 3, and then 3x add 1 to the power becomes 3x squared on 2, and then you've got the plus c on the end as well. A fraction one, just because we like fractions. Of course we do. This is 2x to the power of 3 on 2. That means we add 1 to the power, so 3 on 2 plus 1 is the same as 2 on 2, so that becomes 5 on 2. Okay, and then we divide by 5 on 2. Now I always like to do it a slow way because otherwise I make mistakes. So I divide by 5 on 2, which is really the same as multiplying by 2 on 5, and I end up getting this 4x to the 5 on 5 plus c. Now, you don't need to really put this plus c in until right at the end, okay? So for all the questions that we're doing, it doesn't really matter because all that c recognizes is that there's some constant, and it doesn't matter whether it's, if you put the c up here first or if you put it right at the end, it's just some constant that we don't really need to worry about. And I'll show you where that is a bit more applicable later on. Again, here I've got this one. I can't do the quotient rule, which I would have done for I guess when I'm differentiating, but anti-differentiation, there's no such thing as the quotient rule. So I need to split these up into two things: x cubed on 2 minus 4x squared on x squared. Okay, and then I can do these separately. So x cubed divided by x squared just becomes x, and 4x squared over x squared just becomes 4. And then I just integrate that normally, and I get x squared on 2 minus 4x plus c. I probably should also mention that where x doesn't equal 0, because otherwise this question won't work if x equals 0. Let me show you an example where you can use a substitution to get the answer, but I'll probably prefer you to not use it. But let me show you what it is, and then I'll explain a bit later. So I've got the integration of all in brackets 3x plus 2 all cubed dx. What I'm suggesting, this is one way of doing it. There's another way I'll show you in a little bit. I'm suggesting that u equals 3x plus 2, and therefore du dx equals 3. Okay. Now I don't have du or du dx. I've just got dx. So what I'm going to do is I'm going to transpose this formula to make it dx equals, and I get du on 3. And then I'm going to replace dx with du on 3. So this then becomes u to the power of 3 du on 3. Now that's the same as I guess if I can multiply this across this 1/3 here, it becomes u cubed on 3 du. Okay, and with the integration sign. And then what I'm going to do is I'm going to take that third out the front because I'm allowed to if it's a constant, which in this case it is. So I get a third integration of u cubed du. Now I can do this u cubed du because the u and the u is the same. So I do that, u to the power of 4 on 4, and then I can get, I guess I'll put u back in now because u is something that I've artificially put in. So u equals 3x plus 2 That's all to the power of 4, and the end result ends up being 3x plus 2 all to the power of 4 over 12, then plus c. There is another way to do this question, and this is probably what I would prefer, but that's the technical way of going through it. My original question was the integration of 3x plus 2 all to the power of 3 dx. Now remember what I told you the rules of integration were. We add 1 to the power, we divide by the new power, and then we divide by the derivative, or the diff of the inside. Okay. Now, so for this case here, I'm going to say that it's 3x plus 2. I don't change the bracket. 3x plus 2 all to the power of 4 now, because it's 3 plus 1 is 4, divided by 4, and then divided by, or multiplied down the bottom, which is the same as divided by, the diff of the inside. The diff of the inside here is simply 3. Okay, so the diff of that becomes 3, and then therefore I get the same answer as what I did before. Either method is completely fine. There's no right or wrong way. I guess I would like you to probably know both. This is kind of the shorter way to get the same answer, but this is also acceptable as well. So I think you can now do 7.1 in your textbooks, and in the next video I'll look at 7.2, which is integration exponential functions. So thanks for watching.